with the title of Life, the Universe and Everything is I've got 30 minutes and it's a lot to get through. But let's give it a try. So life, the universe and everything. First of all, who is this strange woman standing in front of you? Well, whenever I'm in front of a distinguished audience, I like to get my CV out there. And so this is me, Maggie Aderin, born in the UK, parents come from Nigeria. I've had a variety of different jobs over the years, but I actually founded my own company, Science Innovation Limited, about 21 years ago. And through that, I'm a science communicator. So I write books, I work on TV, and I also give lots and lots of talks. In fact, over the last 21 years, I've spoken to over 600,000 people. And I must admit, I'm knackered. But it's been absolutely amazing and brilliant fun. So, okay, TV programs. This is the sort of thing I get up to. So I love it because I do a variety of things. So this is sort of the highbrow end, the Sky at Night, longest running science show in the world. And I present that with my co-presenter, Chris Lintott. And I thought, do we really need the moon? Yes, we do. But I do all sorts of documentaries and highbrow stuff. But then I also get to do children's programs, and I love kids' programs. And we look up at the night sky and try and introduce the kids to the amazing universe around them. More recently, I do comedy shows, which is very odd for a space scientist. But I literally just told you, and previously I was doing Ducks, Quacks, Don't Echo on Sky One. And very recently I was doing a podcast for a Netflix blockbuster called Three Body Problem. And when you do a Netflix blockbuster, you get to go to Netflix parties, and it was out of this world. Although I think Mad Festival might have a bit more. I mean, there seems to be a lot going on here, so it's a lot of fun. But yes, I got to go to a Netflix party. But I also write books, and sometimes my books get into the hands of some very famous people. And this is Tom Hanks. And it turns out that this was my book of the moon, and he's a lunatic too. So we had a lot in common. And yes, again, I write children's books. I do sort of grown-up books. And then I do just books celebrating the amazing universe we live in. So I said I was going to talk about life, the universe, and everything. So let's start with life. And the question is there life anywhere other than right here on planet Earth? Because when we look out there, we are searching for life. It's like the holy grail of science. Is there life out there? So how are we going to find it, and what do we look for? Well, we have a variety of life right here on our planet. Life in the air, life on the land, life in the oceans. But the thing is, that is life as we know it. So what sort of life might be out there? And as we've only got life here on Earth, or that's the only place we've found it, how can we look for life, or where do we look? So one of the places we've been looking in the past is something we call the habitable zone. And that is the zone which I like to call the Goldilocks zone, because it's where you'll find liquid water. Now, one of the things we know that all life on Earth has in common is a need for liquid water. And so we're looking for a place that's not too hot and not too cold, but just right for liquid water. And it turns out that the place in our solar system, apart from Earth, that is most likely to do that is Mars. We know that a few billion years ago, Mars had liquid water running over its surface. But Mars lost its water as it lost its atmosphere. So Mars seems like the most likely place we're going to find life. And so we've sent all sorts of rovers there, including a helicopter. So that is the Perseverance rover and the Ingenuity helicopter, which until recently was winging its way over Mars. But now we're trying to find ways. We've sent probes to Mars, and we've been looking for life. But the probes we send are very limited. We are limited in how much stuff we can send into space. So what we're doing now is we're doing a sample return. We are sending a probe to Mars, and we're hoping to bring those samples back to Earth to analyze them, to see if we can find life. The problem is we have to be very careful, because if there is life in these samples, we need to make sure it doesn't contaminate us or damage anything on our ecosystems. But this is a rover which is due to go off in about 2028, and it will bring samples back from Mars. So, where else can we look for life? Well, until recently, we used to think of planets in that sort of Goldilocks habitable zone. But about 20, 30 years ago, we found life where we didn't expect it. We found life in the Mariana Trench. Now, the Mariana Trench is the deepest part of the oceans. It is 11 kilometers below sea level, and we found life there. We thought life couldn't exist here because it's so far away from our ecosystems as we know it, away from sunlight that drives most of the ecosystems. But down here, we found life. And so this has suddenly opened up the possibility of finding life in other bodies in our solar system. Bodies like the moons of Jupiter and Saturn. This is one of Saturn's moons called Enceladus, and it has an icy crust on the outside, but below we know there's liquid water underneath. And we know that because that liquid water sometimes jets out into space and we can see it. And so now, as this moon goes around the gas giant that is Saturn, there might be some hydrothermal activity happening towards the core. And so beneath that icy crust, we know there's liquid water, and it might be powered, life might be powered by hydrothermal activity. So now we're planning missions to land on some of these moons, to actually melt through the ice. The problem is we don't know how thick it is, and actually look for life on these moons of Jupiter and Saturn. But now we're talking about life beyond. One of the most exciting things in space science in recent history is the detection of what we call exoplanets. Now, we have the planets of our solar system, the 8 planets of our solar system, and we can see these with the naked eye. But exoplanets lie beyond that. Exoplanets are actually the planets going around the distant stars we see in the night sky. And with these exoplanets, we are hoping that there might be life out there. The problem is exoplanets are quite hard to detect. And there is this thing called the Drake equation, which was commissioned by Frank Drake in the 1960s. And it's looking at the probability of finding life out there. And it's dependent on all sorts of things. You know, the rate of star formation, how many of those stars have exoplanets around them. We are getting much more understanding of that. We now know that we've detected about 6,000 exoplanets, and we intend to find many more in the future. But there are other factors as well. You know, one of my favorites is, how long does a civilization last? Now, I do lots of sort of public speaking for kids, and I like to put it this way. I imagine sort of, the aliens landing on planet Earth, and their spaceship lands, and then the spaceship door opens, because that's the noise spaceship doors always make. The spaceship door opens, and then the aliens step out, and they look around, and what did they see? Dinosaurs. And so if our civilizations don't overlap, then we're not going to actually meet the aliens. And so this is one of the factors. Another factor is, yes, what fraction of planets develop life? And it's quite interesting, because if you look at our own planet, life almost developed as soon as it could. Because when our planet first formed, it was a hot, lava-y mess. No possibility of life as we know it. But it was peppered with asteroids, and water was brought down, it cooled down. And almost as soon as life could begin, it did. And so this is the questions. Is there life out there? And yes, so these are the exoplanets. We don't really know what they look like, but we can measure their size, we can measure their proximity to their local star. And as I said, we've found 6,000 of them. But with new technology, like the James Webb Space Telescope, we are hoping to find many more. Now, exoplanets, I mentioned the planets in our solar system we can actually see with our naked eye. But the problem is, with exoplanets, because they're so far away, and the star they're going around is so bright, they're really hard to detect. And so one way we detect them is what we call the wobble method. As an exoplanet goes round the star will wobble by a small amount due to the gravitational force of the exoplanet. So that's one method. But the main method we use is what we call the transit method. As an exoplanet goes in front of the star, the light from the star will dim by a tiny amount, and we can actually detect that dimming and work out there's an exoplanet there. But we can do more than that. We can do the science of the seemingly impossible. Because as an exoplanet goes in front of the star, sometimes a tiny fraction of starlight will pass through the atmosphere of the exoplanet, if it has one. And what we can do is we can do analysis of that light and work out that there is what is in the atmosphere. We did this quite recently. A group in Cambridge did this quite recently, and they found in the atmosphere chemicals which seem to indicate there might be life on this planet. Now, getting actual confirmation of, yes, there's life is really hard. But the thing is, the chemicals that they found in the atmosphere of this planet can only be generated by marine sort of bacteria and things like that. And so does this planet have life? That is the question we're trying to answer. But we're getting closer and closer to finding life out there. And it's quite interesting. One of the things I did with Netflix is we were doing all sorts of surveys and things like that and asking the question. And in fact, I'll ask you, how many... There's a news headline, dun, 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 news headline, it's coming in. Yes, we have found the aliens. The aliens are out there. Put up your hands if you're really excited by that. Okay, now, put up your hands if you're absolutely terrified by that. Okay, I'm putting up both hands because I'm terrified and excited at the same time. And it seems that we don't want to be alone. We want to find life out there. And so when there is an indication that there might be life out there, we seem to get very excited. So this is what, the way forward. But yes, not only when we might find life, one of the lovely things would be to actually go out and see it. And yes, we're finding exoplanets with water vapor in their atmospheres. And exoplanets this is a star called TRAPPIST-1, and we've found 7 exoplanets going around it. And 4 of those exoplanets sit in the Goldilocks zone, or the habitable zone, where you're likely to find liquid water. So it's an exciting time for looking out there. Next, I want to go into the universe. Now, the universe is quite a large thing to cover, but what I want to do is talk about how did the universe begin? We talk about the Big Bang, how the universe began, but why do we think the universe began with a Big Bang? Well, to answer that, we need to look back in time. And one of the things I love to point out is that our understanding of the universe has evolved over time. At first, we thought it was, the ancients thought that the Earth was the center of everything. And this seems to be a common theme. As humans, we are very self-centered. We think we're the center of everything. But you could see the evidence they saw. They could see the sun rise, they could see the sun set. It felt as if we were the center of everything. But then people like Copernicus came along and realized, no, we are actually one of the planets going around the sun. And there were things that they used to call wandering stars, and they were the other planets going around the sun. Then we had the invention of the telescope, and Galileo was one of the first people to use a telescope. He didn't invent it, but he was one of the first people to use it for astronomy. And then we have sort of the elliptical universe. We used to think that the planets go around the sun in a nice, tight, circular orbit, but we discovered they actually go around in a squish circle called an ellipse. And then with more and more information, we were able to understand why the planets go around the sun, the force of gravity, which was first postulated by Isaac Newton. And by the 1920s, we pretty much thought we had it sussed. We knew that we were part of a galaxy called the Milky Way. The Milky Way galaxy contained millions, if not billions, of stars. And then, apart from that, there were a few sort of star clusters out there, but that summed up the universe. Then along came this chap. He is Edwin Hubble. And Edwin Hubble is just quite a character. He was 6'3", and he was meant to be absolutely dashing. In fact, there are reports of some women meeting him and actually swooning in front of him because he was just so darn handsome. I would quite like to meet Hubble. But anyway, he worked on the largest telescope in the world in the 1920s at Mount Wilson. And with this telescope, he was looking deep into the universe, trying to understand and gauge the size of the universe. Now, he did this using some work done by Henrietta Swan-Leavitt, this woman here. Now, in the 1920s, there weren't many women in astronomy because, unfortunately, astronomy wasn't that diverse. And, okay, space science still isn't very diverse. But yes, this woman actually had come up with an understanding of a certain type of star. Now, in a minute, you'll see this star. This star is flashing, and this star is known as a Cepheid variable. Now, the flashing of this star indicates how bright the star is. And so if you know how intrinsically bright something is, then and you work out how much light you're receiving from it, you can work out how far away it is. So, using Cepheid variables and actually working out how much light was reaching the Earth, Hubble was actually looking out in the universe. It's called the inverse square law. The further you are away from the light source, the dimmer the light. And so you can work out how far away you are. So Hubble was doing that, and he suddenly discovered that some of these Cepheid variables are beyond the edge of the known universe. They seem to be further away than we anticipated. But Hubble was also using another technique, and it's called Doppler. Now, Doppler, actually, if this works, it's great, but if not, I've got to make some really weird noises on the stage. But let's see if this works. Oh, yes. So this is a train coming towards us. And if you listen to the toot of the horn, that was the train passing us. So when it's coming towards us, it's do, 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 do. The tone of the noise changes, not because of anything the train driver's doing. It's just the nature of waves. As the waves are coming towards us, they get scrunched up, like this. They get scrunched up so the pitch is higher. And then when the train moves away, it's dragging those sound waves away, and so the tone gets lower because they get elongated. The wavelength gets elongated. So that's with sound, but it also works with light. If an object is coming towards us, then the light gets shifted to the blue, and if it's moving away from us, it gets shifted to the red, what we call red shift and blue shift. And what Hubble discovered is when you look out there into the universe, almost everything we observe seems to be red shifted. So everything seems to be moving away from us. And so, well, how do we measure this red shift and blue shift? Well, we use big telescopes. This is one of the largest telescopes in the world. It's called the Gemini telescope in South America. And using this, we are able to actually measure the spectrum of light. This is, and I like to call it making rainbows in the lab, but this is the spectra of our local star, the sun. And when we take that light and break it into its rainbow colors, we see these little dark absorption bands, and they give us an indication of the red shift and blue shift of the objects we're looking at. So using this technique, suddenly we realize how big the universe is, and also that everything in the universe seems to be moving away from us. But that means if you reverse time, everything condenses and comes back. Now, it's quite interesting, because when the term Big Bang was first used, it was actually an insult. What do you think the universe is made out of? We think it all started with a Big Bang. It was actually an insult because people didn't believe it was true. But that's what the evidence seems to indicate, that the universe started with a Big Bang. So now we believe that we are one planet going around our local star, the sun. But all the stars we see in the night sky are also suns, and many of them have planets going around them. In the Milky Way galaxy, we used to think there were 200 billion stars, but now we know there are 300 billion stars, approximately. And we also know, through the Hubble Space Telescope, the telescope that was named after Edwin Hubble, that in the whole of the universe, there are about 200 billion galaxies. Not only are we not the center of everything, we are tiny and insignificant. But I like to see it as we are part of something amazing. Everything. This is one of topics that it's hard to cover everything. But I think what I like to bring it down to is, will we ever reach the stars? All my life, I have dreamed of getting into space, and it's enabled me to overcome challenges which I wouldn't have dreamed of doing otherwise. But when I was growing up, I thought that space and astronomy was just covered by white guys in togas. Because I heard about the Greeks, I heard about the Romans, but I didn't really hear about any other culture doing astronomy. But it turns out that was wrong. There was a whole branch of science called astroastronomy, or archaeoastronomy. And this is an archaeological timeline, looking back through time, and showing that every culture across the world has looked up at the night sky. In fact, one of the things I like to believe in is that, before people could even speak in words, there were cave people, sitting around a campfire, looking up at the night sky, ugh, ugh, ugh. Because I think it's something that's inherent in all of us. Recently, we've been having some nice clear nights, and not very long nights, but nice clear nights. And if you just see the moon or the stars, it makes my heart sing. And I think it does that for most people. So I think there's something fundamentally in all of us that enjoys the night sky. That's quite interesting because I get to do all sorts of projects. And a few years ago, I was working with English Heritage. And in fact, on the 21st of June, just last month, I went out to Stonehenge for the summer solstice. So when I was doing this project, I was able to stand in Stonehenge all on my own. But I've also been there for the summer solstice and been there with 10,000 other people. And Stonehenge isn't the oldest stone circle in the world. Stonehenge is about 5,000 years old, but the oldest stone circle in the world actually sits on African soil. This is called Nabta Playa, just sort of south of Namibia, just north of Namibia, and it's the oldest stone circle, over 9,000 years old. And if you look across the world, every culture has looked up. This is something called an astrolabe, which were perfected by the Arabic community. And this is a beautiful example of it, because it's a scientific instrument, but it has wonderful engravings on the surface, and also words from the Quran on its edge. In the Central American cultures, they built pyramids to celebrate the night sky. And so all of this I didn't know as a child, but I still was reaching for the stars. I still had that crazy dream of getting out there. And so this is me when I was about 4 years old. And I would have loved to have a picture of me epically looking up into the night sky, contemplating the universe. But I've actually dropped my ice slightly and I'm trying to pick it up before my parents catch me. So not the most glamorous start. But that idea about getting out into space stuck. And I think it's about hearing about people like Yuri Gagarin, the first person into space. And also, Neil Armstrong, and one small step for man, one giant leap for mankind. Those were the words echoing in my ears as I was growing up. And so I decided then and there I wanted to get out there. Also, there's a few embarrassing bits. The clangers. I don't know if you're familiar with them, but these little creatures captured my heart. And I thought, yes, I want to get out there and meet the clangers. And it turns out that the clangers are a gateway drug. Before I knew it, I was a Trekkie, live long and prosper. And so these were the influences on my young life. And Lieutenant Uhura, it's funny, because this was a mad festival, I was really tempted to come in a Star Trek uniform, but I decided against it. It's a bit warm for that. But yes, Lieutenant Uhura was my absolute role model. Growing up in the 1970s, there weren't many black people on TV, so seeing Lieutenant Uhura just made my heart sing. And so my dream when I was about 7 years old was I wanted to travel into space and see the curvature of the Earth just as Yuri Gagarin had done. Then I wanted to go to the moon and walk next to the footsteps of Neil Armstrong. Then I wanted to travel and meet the clangers. I was only 7. But finally, what I wanted to do was I wanted to reach for the stars. I wanted to travel to those exoplanets that we're detecting now. But for me, it all went horribly wrong when I went to school. You see, I am neurodiverse. I have a condition called dyslexia. Now, in the past, I say I suffered from dyslexia, but dyslexia I see as my superpower now. But also one of the other challenges I faced is I went to 13 different schools when I was growing up. Now, when I said this to one kid the other day, she looked at me and said, "How naughty were you?" It wasn't like that. My parents split up when I was 4, so sometimes I was with my mum, sometimes I was with my dad. Some schools just closed, I didn't touch them. But it meant, with the dyslexia and going to 13 different schools, it meant my education was quite chopped up. And so I was usually at the back of the class with the safety scissors and the glue, and no one really expected anything of me. But because I had this crazy dream, it kept me going. I kept on thinking, I'm reaching for the stars, and I was looking for any opportunity that would allow me to get there. And so now I'm an ambassador for organizations like Made by Dyslexia, and they champion dyslexic thinking. But the turning point came for me when I got to my 13th school, and they said, well, what stream should you be in? Top stream, middle stream, lower stream? All my life I've been in the low of the low at the back of the class, but this was my opportunity to make my crazy dream come true. And so I said, yeah, I think I should be in the top stream. And they put me in the top stream, and I didn't watch TV for 2 years, and that's when Dallas was on. But this was my opportunity to reach for the stars. And so with lots of help of support from parents, from teachers, I was able to get my GCSEs, my A-levels, and then go on to Imperial College and get a degree in physics and a PhD in mechanical engineering, which is why I'm sort of Dr. Maggie today. But the things I've learned is I think we really, in all our walks of life, we need to think big and think crazy. Too often we limit our expectations. And for me, I've always been thinking big and thinking crazy. And that enables me to do things I would have never thought possible. But we're doing the same in astronomy as well. This is a group of telescopes, the largest telescopes in the world, and they're 8 4-meter telescopes. And they chopped off at the top of a mountain on the driest place on Earth in the Atacama Desert and built these 4 telescopes. And they have a very simple name. We call them the VLT. And that stands for Very Large Telescopes. We're not talking small, eeny-meeny telescopes. We're talking big telescopes. So the VLT is 4 large telescopes in the Atacama Desert. But yes, these are the largest telescopes in the world at the moment, but now we're looking to build the next generation. We call them the ELT, the Extremely Large Telescope. The VLT is 4 8-meter telescopes. The ELT is 1 telescope, but the primary mirror is 39 meters in diameter, 39 meters of light-gathering power. And so now we're actually building the ELT. And my daughter and I went to visit out about 18 months ago, and it was mind-boggling. The whole thing is about the size of a stadium. Yeah, so it doesn't sit next to Big Ben, but it is as tall as Big Ben, and it is a mind-boggling thing. But the telescope I hope to see in my lifetime we call the OWL, the Overwhelmingly Large Telescope. And if we build this, the primary mirror will be the size of a football pitch, 100 meters in diameter. And so, yeah, we started off with these small telescopes, like the sort of thing that Hubble was using, and we've gone on to build bigger, better telescopes so we can get a better understanding of the universe. And things like the James Webb Space Telescope, largest space telescope ever built, out there looking into deep, dark space. And so, yes, my crazy dreams. Now I'm an ambassador for Made by Dyslexia. Also, I work for the International Rescue Committee. And dyslexic thinking is powerful. I used to say I suffer from dyslexia, but I see that my dyslexic thinking makes me a better communicator, makes me more empathetic. Many of the dyslexic traits are what we need in our everyday work. And that's what it's all about. It's about diversity, mixing it and matching it. When I first started working, I thought I had to do everything, and I find things like report writing and stuff like that really hard. Me being an author, I still can't quite clock it, because I know how hard it is for me to write. But what I realize is that when we work in teams and collaborate, the things that I find hard, other people find easy. And so when we work together and get that diversity going, we bring ideas together and we can change the world. But crazy dreams do come true. I mentioned that my love for the clangers as a small child. Well, because in every interview I've done, I said I became a space scientist because of the clangers. When they were rebooted a few years ago, they actually made an episode and put me in it. So I am in an episode of the clangers called The Visitor, and it's available online. Crazy dreams come true. This is one of my crazy dreams, because this is my lovely daughter Lauren. She's a bit bigger now. Actually, she's taller than me. She's holding a clanger, but the person she's sitting next to is an actress called Nichelle Nichols, who played Lieutenant Uhura. I got to meet Lieutenant Uhura, and she brought tears to my eyes. She was just so lovely. But one of the things I've learned is that together we can achieve the seemingly impossible. And so many things just feel insurmountable, as if we can't do them. But we can do them when we work together. We're looking at going back to the moon, getting the first woman to go to the moon. So far it's been 12 white guys from America. So they need someone from a different ethnicity, someone who isn't male, someone maybe from the UK with dyslexia. I'm just suggesting. We are looking to go back to the moon. And I don't know if I'm going to make it, but this is probably the woman who will. She is a NASA astronaut, and she is billed to be one of the first women to go to the moon. And look at the moon. I'm a self-certified lunatic because I love the moon, but we are talking about building on the moon and actually having moon bases out there. And then onto Mars. NASA said quite recently that the first person to land on Mars, so our first Martian, is alive today. I'm hoping it's me, but it's probably going to be someone a lot younger. But sometimes looking at the Earth from space can change our perspective. This is a picture called Earthrise. And when the Apollo astronauts who didn't land on the moon took this picture, they said that everybody on Earth needs to see this, because it's seeing our planet in a very, very different light. It's seeing our planet as small and vulnerable in the dark velvetiness of space. And from this viewpoint, people think that that's what inspired the environmental movement in the 60s. So sometimes a different viewpoint, and the viewpoint from space, can be quite changing. And so there are problems that seem insurmountable, but when we collaborate, we can change the world. I was invited up to COP26 a couple of years ago when it was up in Glasgow, and there we were talking about some of the challenges that we face. And I met a fantastic woman called Cristina Ferriguez, and if you get a chance, please look at her TED Talk, but she talks about something called stubborn optimism. Stubborn optimism is a combination of optimism, which gets you out of bed in the morning and sort of keeps you going, but optimism isn't enough. You need the stubborn grit and determination to keep going and to work with others. So stubborn optimism is what we all need. I'm just going to finish off really quickly. I said my crazy dream is reaching for the stars. And I want to show you the challenge of doing that. This is our solar system over here, and that there is the next door neighbor solar system out of the 300 billion solar systems in our galaxy. So that sits 4.28 light years away. Now, a light year is the distance that light travels in a year, and so that is equivalent to 40 trillion kilometers. Now, traveling as fast as we can through space at the moment, we can travel at 16 kilometers a second. Now, I traveled in from Guildford earlier, and I would love to travel at that speed. But even at 16 kilometers a second, that journey from our solar system to the next door neighbor solar system, that journey will take 76,000 years. So my crazy dream of reaching for the stars truly is crazy. But that doesn't stop us. The late, great Stephen Hawking was championing a new project called Breakthrough Starshot. Breakthrough Starshot is using an existing technology, but in a different way. This is something called a solar sail, and we've used them and had light from the sun accelerating them in space. But now what we want to do is use the solar sail not to actually use sunlight, but we want to use lasers to accelerate them. The lasers will send a pulse of light into space. They will hit the solar sail, and they will accelerate the solar sail to 1/5 of the speed of light. If we do this, we can get this solar sail to travel to the next door neighbor star system. So there it goes. It's got the pulse of light. It's traveling out to the next door neighbor star system. But the thing is, we have to be very careful. So there's our solar system receding into the background, and it's heading out to the next door neighbor star system. Now, when it gets there, we cannot slow it down. We can accelerate it using the light, using those photons, but we can't slow the solar sail down. And so what it will do is it will fly past first the star and then the exoplanet. So the only thing we can do is grab photographs as fast as we can, take images of that exoplanet, and then beam them back to Earth via radio waves. If we can get to do this, we might be able to get the answer to the question, is there life out there? And this is quite mind-boggling, because not only will we actually be able to sort of try and detect elements in the atmosphere, we will actually take pictures of the planet and see if there's life out there. But if we can get this technology to work, that journey of 40 trillion kilometers, it won't take 76,000 years. We'll be able to do it in just 20 years. And so this is my crazy dream. I'm getting closer to reaching for the stars. But there's a few caveats. If the solar cell, the solar cell we send, the probe we send, can weigh no more than about 1 gram. I had a good lunch here. I weigh a lot more than 1 gram, so I'm not getting out there anytime soon. But the idea that we can take images of an exoplanet and beam them back to Earth is mind-boggling. So I say keep asking questions and keep reaching for the stars. Throw away the old traditional. Keep it, but do something new at the same time. And have big, crazy dreams. It's definitely worked for me. It can work for you too. Thank you so much for listening.